Hey everyone, before we start talking about concurrency in Golang, let us first understand the difference between sequential and concurrency in programming. Understanding these concepts will help us to understand concurrency in Golang better. Talking about sequential programming, sequential programming is the simplest form of programming. In sequential programming, the commands or instructions are executed one after another in a linear fashion. This means that the next command or instruction cannot be executed until the previous command is entirely completed. For example, in a program that calculates the sum of two numbers, the first instruction would be to ask the user to input the first number. The second instruction would be to ask the user to input the second number. And the third instruction would simply calculate the sum. Once we have the sum, the fourth instruction would be executed, which is to return the sum of the two numbers. Now, sequential programming is often used for simple programs where the commands or instructions are not dependent on each other. But hey, CPU is a super fast device, and keeping it occupied for a single task is never a good idea. This is where multitasking comes in the picture. Multitasking is the ability of the operating system to execute more than one task simultaneously on CPU. This basically happens in CPU by switching between jobs using a small time quantum. When we talk about multitasking, we generally refer to a single core processor, but it switches from one program to another so quickly that it gives the appearance of executing all of the programs at the same time. Now, what is concurrency? We can say concurrency is the notion of multiple things happening at the same time. It's basically the potential for multiple processes to be in progress at the same time. We can also say that concurrency is achieved through multitasking. Now, concurrency in multiple core CPUs would look something like this. There are two cores and two tasks. Each core is executing both tasks by switching among them over time. This system is also known as multiprocessing system, where CPU cores are added for increasing computing power. However, we should not mistake concurrency with parallelism. Parallelism refers to using of multiple processing elements simultaneously for solving any problem. For example, here the parallel approach does not switch among tasks, but instead executes them in parallel over time. A simple example for concurrent processing can be any user interactive program like a text editor. In such an application, there could be many concurrent operations going on, such as saving the file and typing at the same time. In this case, all of these operations might look like they are happening simultaneously, but that's not the case. In contrast, for parallel processing, we can think of a Hadoop-based distributed data processing. It involves large-scale data processing on many clusters, and it uses parallel processors. But programmers see the entire system as a single database. Well, that's it for this lecture. We'll see you in the next one.